In this video, we will talk about a new way of harnessing wind energy offshore, floating offshore wind turbines. Floating offshore wind turbines refer to wind turbines that are installed on a floating support structure, which is moored to the seabed. As we will see in this video, there are many different concepts of floating support structures currently under consideration. This is in contrast to conventional offshore wind turbines, whose support structures are directly mounted on the seabed. As of 2019, all commercial offshore wind turbines are still bottom-mounted. But as we will see shortly, floating offshore wind turbines could be very attractive. So after watching this video, you will be able to explain why there is a need for developing floating offshore wind turbines. You will also be able to discuss some of the recent developments in the field of offshore wind energy. And you will be able to outline some of the key challenges that need to be overcome in order to further commercialize this technology. This slide shows the average water depth and distance to shore of bottom-mounted offshore wind farms in Europe as of 2018. The size of the bubble indicates the overall capacity of the site, whilst the color shows the development status. As you can see from the vertical axis on the figure, all bottom-mounted wind farms are installed in waters that do not exceed 50 meters depth. This is due to the fact that installing wind farms in deeper water is increasingly expensive. Since a fixed support structure has to extend down to the seabed, the amount of material and the hydrodynamic loads on the structure significantly increase with the water depth. If we look at the typical water depth in Europe, however, we see that most seas are actually deeper than 50 meters. This is shown by the light and dark blue areas on this map. And this observation also holds true across the globe. This means that by using bottom-mounted foundations, which are limited in terms of water depth, we also significantly limit the geographical locations where offshore wind farms can be installed. If floating support structures were used instead, the range of possible sites would largely increase. Floating offshore wind turbines therefore open up new markets, especially in regions of high wind speed, thus potentially largely increasing the overall wind energy produced. As already mentioned, there are many different concepts of floating support structures currently under consideration. These concepts of floating support structures are usually divided into 3 or 4 categories: tension leg, semi-submersible and barge, and spar buoy. These categories differ in many ways, such as their stability criteria. More specifically, tension leg platforms, also called TLPs, are kept stable through the use of tethers under high tension. The motion of this type of platform is therefore quite limited, in particular in heave, so for translation along the vertical direction, and pitch, so back and forth rotation. Semi-submersible and barges, by contrast, are kept stable by their large water plane area, meaning that they present larger geometrical inertia and can exhibit larger wave-induced motions. Finally, the spar buoy concept consists of a long monopile that is ballasted in order to ensure stability by lowering the center of gravity of the system. This is one of the simplest support structures, but it needs to be deployed at large water depths of at least 100 or 150 meters because of its large draft. Let's look at a few examples of floating offshore wind turbines that have been developed over the years. It started small scale with an 80 kilowatt TLP prototype installed off the coast of Italy in 2007-2008 by the company Blue Water. A year later, the first large-scale floating wind turbine was installed by the company Statoil, now called Equinor. That was the so-called Hywind turbine, a 2.3 megawatt turbine installed in the Norwegian Sea and supported by a spar buoy. As of 2018, 5 6 megawatt Hywind turbines are operating off the coast of Scotland. WindFloat is one of the most famous submersible floating wind turbines. It was installed in 2011 off the coast of Portugal by the company Principal Power. A farm of 25 megawatt is now under development in the Atlantic Ocean. Floating offshore wind has also a large potential outside of European waters. For example, many activities are taking place in Japan. Following the nuclear accident in Fukushima, 3 floating wind turbines were installed and are fully operational since 2016. These are turbines with rated power between 2 and 7 megawatt placed on a semi-submersible support structure. Other floaters like the barge concept are also being tested in Japanese waters. Although floating offshore wind energy is a promising concept to harness new markets and increase the share of wind power, it also presents some interesting engineering challenges. From an aerodynamic point of view, the rotor loads and operation are very different than for a classical bottom-mounted turbine. For most of the floating support structures, the pitch motion of the system might be significant, meaning that the rotor will interact with its own wake during operation. These interactions are challenging for the design of both the rotor and its controller. From an hydrodynamic point of view, the design of the floater needs to be further optimized in order to decrease cost for a given turbine rating and size. The mooring lines suffer from dynamic loads, which can cause critical fatigue failures and require better understanding of and modeling approaches. Similarly, the electrical cables used to retrieve the electricity back to shore will also be dynamically floating, hence suffering from the same challenges. Finally, the dynamic motion of the system can bring new opportunities in the installation phase. However, it also brings challenges for the operation and maintenance of this system, especially if they are installed in deeper water with harsh environmental conditions. Overall, new design standards need to be developed in order to ensure safety and cost-effectiveness of these new concepts. The various demonstrators that have been installed in recent years prove that floating wind turbines are technologically feasible. However, work is needed to make them competitive with existing offshore wind turbines. To conclude, in this short video, we outlined a novel way of harnessing wind energy in deep water. Many different concepts are currently being explored, and it is still unclear which one will break through for large-scale commercialization. We also mentioned some of the key challenges that need to be solved to make this technology a real game changer in the offshore wind industry. As we saw, the offshore wind energy field is still open to many innovations.